Mathematics 2, May 2016 exam. Question 8. Differentiate the following expressions with respect to x. We can differentiate a in one of two ways. We could expand the brackets and get a cubic equation and then differentiate that, or we could do it as using the product rule. If you can't remember the product rule, just go and have a look at the standard differentials. It's UV here. I'm going to use the product rule. So this is u and this is v, and the dy by dx is equal to u dv dx plus v du dx. So that's equal to u, which is the same as that, and then the differential of this is going to be 1. The x remains and the 3 will go, and then it's v and then du dx. So the differential of this is going to be 6x and the 4 will disappear. We'll tidy this up a little bit. We're going to get 6x squared from there and 3x squared from there. We're going to get 18x from there, and we're going to get a minus 4 from there. So that gives us 9x squared plus 18x plus 4. Okay, part B. 4x cubed is going to be u, and cos 3x minus 2 is going to be v. So dy by dx is equal to u, which is 4x cubed, which is there, dv dx, well, the differential of cos is minus sine, so we're going to get a minus sine 3x minus 2, and then this is a function of x, so we then need to differentiate this. So the differential of 3x minus 2 is going to be 3, which is where that 3 comes from, and then we're going to have cos 3x minus 2, and then the differential of this is going to be 12x squared, 12x squared. So I'm going to take, I've got a 3 here and a 4 there, so there's a 12x squared, which is common to both terms. I'm also going to put the cos term first because it's positive. So we can tidy that up a little bit. 12x squared outside cos 3x minus 2 minus x, that was a cube, not a square, x sine 3x minus 2. Part C. We're going to use the product rule for this. U is going to be e to the 3x and v is going to be cos 2x plus 5. The differential of cos is minus sine, so there's the minus sign. We've got 2x, so the differential of that is going to be 2, which is where that 2's come from, and then e to the 3x. And we're going to differentiate e to the 3x, which is going to give us 3e to the 3x times cos 2x plus 5. We've got e to the 3x is a common term in both parts of the expression, so we can put e to the 3x outside. I'll put the cos first because it's positive, so it's 3 cos 2x plus 5 minus 2 sine 2x plus 5. D, we're going to use the quotient rule. The numerator is u and the denominator is v. So it's going to be v du dx minus u dv dx over v squared. If you can't remember that, just check the equations on the back sheet. U over v is v du dx minus u dv dx over v squared. So that gives us v du dx, the differential of cos is minus sine, and then we've got the 3x, which gives us a 3 there, minus u times dv dx, that's going to be 12x squared plus 6x minus 4, 12x squared plus 6x minus 4, divided by v squared, which is the bracket there. And really there's not much we can do with that in terms of simplification, so I suggest you leave it like that. And then part E, we've got the another quotient, log x, log 3x is going to be u, and x cubed is going to be v. So we've got v du dx. Let me just show you that. If you've got log ax and you want to differentiate that d by dx, you're going to get 1 over ax times the differential of the argument, so that's going to give you an a, so the a will cancel. So we've got log 3x there and we just get 1 over x, the 3 will cancel. So we've got x cubed 1 over x minus log 3x, which is u, times dv dx, which is going to be 3x squared divided by x to the 6. Now we've got x cubed and 1 over x there. We've got x cubed and 1 over x, so that will give us x squared. And we've got 3x squared here times the log. So I can divide top and bottom by x squared, which will give me 1 minus 3 log 3x over x to the 4.